So as you may or may not know, physics is really an applied math. So it's using relationships, numbers, formulas to help explain everything that's going on around us and explain why things happen the way they do in relation to motion, energy, electricity, magnetism. And in order to work with all of these formulas and relationships, we need to review some of the basic math skills. So we're going to spend probably a couple days just reviewing some of the basics that are going to help you be successful with working with all the formulas that we're going to learn throughout the course. So the first thing we're going to look at is uncertainty in measurements. So when we think about quantities, so when we measure things, there's two values that we talk about. One is exact values and one is measuring values. Exact values are defined quantities. So let's say the relationship 1 meter equals 100 centimeters. And counted values, if we're counting something, how many of something, 5 beakers or 10 trials. But measurements, they're not as exact. And when we measure things, there's always some degree of uncertainty or error associated with it. So in terms of making measurements, which is what physics is all about, before we even use them in formulas, there's something called significant digits. And this is something you may or may not be familiar with. We're going to spend time going through every part of how to work with significant digits. So if you know nothing about it, we're starting right from scratch. So you might be asking yourself, why do we need to know this? So let me just give you an example. In physics, we're given numbers that may have been measured numbers, and then we have to put them into a formula and solve for a final value. Well, that final value can only be as accurate as our least accurate measurement that we took. And so this is where significant digits come into play. What we just need to know is when we get our final answer, how many numbers or decimal places should we include in our final answer? And in order to understand that part of it, we have to go back and know, well, what is significant and what's not significant? So that's what this video is going to start off with. So by the end of this lesson, what you should be able to do is I should be able to give you a number, any number, and you should be able to tell me how many significant figures are in that number. Because first we need to be able to identify how many significant figures exist in a number before we can then decide what's going to be in our final answer. So first part of it is, let's look at the left-hand side of this column and decide all the numbers that end up being significant in any value. Okay, so first category of significant figures. Any numbers that are between 1 and 9 are considered significant. So what we're going to do is just put an example of each under each one. So if I gave you the number 154, how many significant figures are in this number? Well, all numbers between 1 and 9 are significant. So there's 1, 2, 3. So it has 3 significant figures. Okay, and the SF is just to represent how many significant figures we have. Okay, the next example of when a number is significant or a value is significant. Trailing zeros just mean zeros that occur at the end of a number. And if there's a decimal point present, so this is key, if there's a decimal point in your number and you have zeros that are after or occurring at the end, then those zeros count. So I'm going to put an example just to show you what that looks like. So an example could be 534.0. 5, 3, and 4 are rule number 1. They're all 1 through 9, so they each count. So there's 1, 2, 3 significant figures here. And because we have a decimal point, this trailing 0 or 0 at the end also counts. So we actually has, this one has 4. Oh, my pen's not working here. Has 4 significant figures. Okay, I'm going to jump over to the other side of the chart right now because it kind of makes sense. Trailing zeros, if a decimal point is present, do count as significant, but when there's no decimal present, they don't count. So let's look at an example of that. Let's take a similar number. So 5, 3, 4, 0. Now these are very different numbers. 534 is different than 5,340. But what we just want to learn here is, doesn't matter what number you have in front of you, are they significant or are they not? So the same rule applies: significant, significant, and significant, because they occur 1 through 9. This trailing 0, because there's no decimal point, is not significant. So this actually only has 3 significant figures. Now I'm just going to interrupt myself here right now because I just want to let you know, you might hear some sounds in behind me. I'm at home and I have 2 dogs and they like to bark occasionally, so that's what you might be interrupted with. Okay, so back to the last rule for when a number is significant. We covered up here to start that any number between 1 and 9 in any number that you have, or any value between 1 and 9 in a number, counts. What happens when we have a 0? If the 0 is occurring between one of the numbers between 1 and 9, then it's significant. We count it. So I'll give you an example so you can see what I'm talking about. If we had 1,037, okay, the 1, the 3, and the 7, that's rule number 1, right? Any number between 1 and 9 counts, so those are all significant. And this is telling us that a 0 that occurs between any of those numbers is also significant. So we have a total of 4. Okay, so 3 different scenarios to consider whether a number is significant, and 2 different scenarios to consider whether it's not significant. So we just have the one last one when it's not significant. We just finished talking about zeros that occur between numbers, and we've talked about zeros that occur at the end of numbers. If there's a decimal, it counts. If there's no decimal, it doesn't count. What happens when we have zeros at the beginning of a number? Okay, when we have zeros at the beginning of the number, there's usually always a decimal point present, right? So I'll give you an example. 0.0325. Leading zeros never count. Okay, so leading just means the zeros at the beginning, trailing means zeros at the end. There's only one rule for leading zeros, and it is that they are never significant. So 0.0325, these don't count, these 2 zeros, because they're leading zeros, and these numbers do because they fall under this category, right? They're numbers between 1 and 9. So this number has 1, 2, 3 significant figures. Okay, so that sort of sums up the rules on whether numbers are significant or not. And just so you know, when I make my video notes, you always have the option of coming back and replaying them, but I'm also including a PDF copy of the actual notes. So if you don't want to go back and rewatch the video, you can just sort of scan through what the answers are. And just so you know, they may not match exactly what I'm doing here, because what I did was I posted PDFs from when I had taught the course last, and the videos are new. All right. Okay, so now on to rounding of calculated answers. When we get our final answer and we decide how many significant figures it should have, we're most likely going to have to learn how to round. Okay, so if the first digit to be dropped is 4 or less, the digit to its left is not changed. So let's just look at a couple of examples of this. If we had to, so you may be asked to round 5.83 to 2 significant figures. Well, 5.83 is 1, 2, 3 significant figures, but we need to round it to 2 significant figures. This is where we're eventually leading up to. So what you do is you decide, let me use a different number or color here. We want 2 significant figures. This one's significant and this one's significant. So we want it to end here. And where you decide it's going to end, you only look one spot to its right. Okay, and if the first digit after where you're ending is 4 or less, the digit to its left is not changed, it stays the same. So our answer would be 5.8. What if we had to round 5.85 to 2 significant figures? And that's rule number 2. If the first digit to be dropped is 5 or more, the digit to its left is increased by 1. So we know both of these are significant and we want 2. So here's our 2 we want to keep. We need to drop this, but we just have to ask ourselves, which of these rules does it fall under? Is it 4 or less or 5 or greater? This guy's 5 or greater, so it bumps this number up by 1. So this one would be 5.9. Okay. Now I want to look at one specific example that I know the reason I want to look at it is because I always come across a few examples throughout the course where people commonly make this mistake. So I want to address it now and hopefully prevent that mistake from happening. I'm going to give you an example to work with. If we had to round, let's say round 5.8548 to 3 significant figures. So we want to round this number to 3 significant figures. Well, these are all numbers that occur between 1 and 9, so they're all significant. So we always start at the beginning and say, okay, we need 3. So this is our first significant, second, third. We want it to end here. Okay, you always look 1 to its right, and it's a 4. Here's where the common mistake occurs. People think that because beside this 4 there's a number that's greater than 5, it bumps this up to 5, and then this 5 bumps this up to 6. Don't do that. You're only ever looking one value to its immediate right. You can ignore everything after it. It's this place value that determines whether this increases or not. So this would actually stay the same and be equal to 5.85. Okay, so don't ever look further than that. And I actually put a note down below. So note, only use the digit immediately to its right of the final significant figure that you've decided to keep. Okay, so on to scientific notation. In physics, we deal with a whole bunch of really, really, really big numbers, like let's say distances between planets and lengths in the universe. And then we also deal with really, really, really small numbers, like let's say distances between atoms or sizes of electrons and protons. So we can't always write our full out numbers in standard form, which we call it. Okay. We need to come up with a method because sometimes we just don't have room even to enter it in a calculator. There's only so many values that you can enter. So what we've come up with is what's called scientific notation to help deal with really big numbers and really small numbers. So standard form is the way we've been writing it so far. So let's just say we had 53,000. We call this standard form. And if we wanted to convert this to scientific notation, what we do is we want the decimal place to end up after the first number that's between 1 and 9. So right now, we don't see the decimal point, but because we know 53,000 is a whole number, that decimal point is technically here. We just don't show it when it's at the end. Where we want it to be is between the 5 and a 3, right after the first digit. So what we have to do is count how many places it's going to go over. 1, if my pen will cooperate, 1, 2, 3. So it's got to move over 4 place values, okay, and to the left. So our scientific notation then becomes 5.3 times 10 to the 4. Okay, now let's look at the opposite example, and I'm going to show you how you can know whether what to do with your exponent. So let's look at this number, standard form. This is a really small number, 0.00025. And we want to convert this number to scientific notation. Well, in this number, we see our decimal point is over here. The same rule applies for scientific notation. We always want it to end up between the first and second number that occurs between 1 and 9. So these are all zeros. They're not significant because they're leading zeros. And here's our first number between 1 and 9. We want the decimal point to be between the first and the second. So how many spots does it have to move over? 1, 2, 3, 4. 4 spots. So in this case, 2.5 times 10. And now here's the difference. Up here we moved to the left, and over here we moved to the right. And how that changes your scientific notation is whether your exponent is going to be negative or whether it's going to be positive. Okay, and this is also something that people commonly confuse. How do I know whether my exponent should be positive or negative? A general rule of thumb is it's going to be positive for very large numbers, and it's going to be negative when they are less than 1 or very, very small numbers. So that's kind of a general rule of thumb that you can help remind yourself of whether your exponent will be positive or negative. Okay, and just a final note about using scientific notation with your calculators. This is something you may or may not be familiar with, but you all have a button. You will definitely need a scientific calculator for this course. And all scientific calculators have a button that's called an exponent button. It might look a little bit different on each calculator, but generally the two that are most common, it might be EXP or EE. And what this does for you is, because scientific notation always involves times 10 to the exponent of something, when you hit this key, that's what it's entering for you. It's entering times 10 to the exponent of. So you just have to hit that key, and then all you have to do is enter your exponent after. So entering this number in your calculator, 7.5 times 10 to the 4, this is what you would do. You'd put 7.5 in your calculator, hit your exponent key, and then all you do is you tell it what exponent's going beside the times 10. Okay, and if it's negative, you have to figure out with your calculator, are you entering the negative before or after the number? Because I know that sometimes changes depending on the type of calculator. So I just want you to practice. So if you don't have a scientific calculator in front of you, get one to try this next step. What I'm going to have you do is enter each of these in and multiply them together. So what I want you to do is tell me, or at least practice with your calculator to make sure you can get this answer. So 7.5 times 10 to the 4, this is definitely something you're going to need to do throughout the course, so you might as well get used to how your calculator works for you. So 3.6 times 10 to the negative 3. We're going to multiply these two numbers together, okay? Remember, any between brackets just means multiplication. There's no operation in between them. So what I want you to do is use your calculator, and using the exponent key and entering it, multiply these numbers, and make sure that using your calculator you can come up with a final answer. And your calculator may do one of two things. It might give your answer in standard form, in which case your answer should be 75,000 decimal 0036. Your calculator may also give it to you in scientific notation. And in this case, your answer may be 7.5 times 10 to the 4. But what I want you to do right now is practice using your exponent key and make sure that your calculator is giving you one of these answers. Because if it's not, you have to play around with the order that you're putting it in your calculator, and I want to make sure you get comfortable with how your calculator works. Okay, so now we're basically to the final goal of why we needed to learn what significant digits are. Remember, I told you in this course you're going to be doing lots of calculations, working with lots of formulas, and when we get our final answer, we have to decide what our final answer should include in terms of significant figures. And there's two rules. If you're multiplying and dividing, which is, I'm going to say right now, most common, I'm going to say 99% of the time you're using this rule in this course. And that's because almost every single formula involves multiplying and dividing. I can't think of one formula that only involves adding and subtracting, but we need to learn both rules. So if you're multiplying and dividing, the rule states that your final answer should include the least number of significant digits from your starting values, from whatever you started with, whatever your given values, so the numbers that they supply you with to put into your formulas, you look at those. So let's just say we had a word problem, and the numbers they gave us were 23.0 times 43, and we were multiplying them. Sorry, 432 times 19. Okay, we can put these, this is in our calculator, there's a decimal point here. So 23 times 432 times 19. When I put that in my calculator, I get 188,784. Okay, this is our final answer. This is what our calculator spits out at us. But the final step you always have to get in the habit of doing is asking yourself, how many significant digits should this final answer have? We have to look at our starting values. Okay, the first one has 1, 2, 3. All of these are significant. These because they're between 1 and 9. This because it's a trailing 0, but there's a decimal point present. So there's 3 here. All 3 of these are between 1 and 9, so we have 3 significant figures here. And 19 only has 2. So this rule says your final answer can only have the least number that you started with, which means we have to have 2 in our final answer. So if we look at what we want to round this to, this is significant and this is significant. We want to stop here. So we want to look at this next number, and this is going to decide whether this gets bumped up or stays the same. And because it's greater than 5, it gets bumped up. So this becomes 190,000, okay? So once you've changed it, every place value after that just becomes zeros. So 188,784 has too many significant digits, so we have to round it to the least number by doing this, okay? Or the other way you're going to also commonly see it is in scientific notation. So these two numbers mean the exact same thing, just two different ways of expressing it. Okay, so either or is acceptable. In scientific notation, when we're deciding how many significant figures there are, it's always just this first half you're looking at. How many significant figures are occurring right here? And there's 1, 2. And that's what we had to have in our final answer. Okay, that's the only difference with scientific notation. Now, when we're adding and subtracting, it's similar but just a tiny bit different. If we're just adding and subtracting, it's still the least number, but it's decimal places instead of significant figures. Okay, so I'll show an example and then you can see what I mean by just decimal places. So we're just ignoring significant digits right now when we add and subtract, and we just focus on how many numbers occur after the decimal. So I'll give you an example. So 123.5 plus 46.0 plus 86.257. And when we put that into our calculator, we get 255.757. And it's telling us our final answer can have the least number of decimal places that we started with. So let's see how many. We've got 1 decimal place here, 1 decimal place here, and 1, 2, 3 decimal places here. Our final answer has to have the least number, so we have to round it to 1 decimal place. It means we have to stop here. So we only look to its immediate right, and it tells us that we're going to bump that up by 1. So our final answer is 255.8. And here's just a little summary sheet of what to do. So when you're adding and subtracting, it's the fewest decimal places. When you're multiplying and dividing, it's the fewest number of significant digits. And this is what we're talking about here, is what do we put in our final answer? And any multi-step calculations, this is a really, really good reminder. Leave all your digits in the calculator until you are finished, right till the very, very end. Even if you have multi-step or you're using one answer to find something else out in a different answer, don't round anything and don't leave any digits out until you get to the final answer. Okay, and so a combination of addition and subtraction and multiplying and dividing, you're going to follow the rule for multiplying and dividing, which is why I said 99% of the time you're using this rule. Okay.